everyone, welcome back to the channel Capsulated Breakthrough. I welcome you all once again. As you all know, my name is Syed Irfan. I am pursuing Electronics and Communication Engineering in Sri Venkateswara College of Engineering. So today's topic to discuss upon is addressing modes. Addressing modes is a topic which comes under the subject computer organization, which is the semester 3 subjects in electronics. So what are we going to study in the addressing modes in the upcoming video is that we will be studying types of addressing modes, which include immediate addressing modes, direct addressing modes, indirect addressing modes, index addressing modes, relative addressing modes, and auto increment. So moving on next. So before we start anything, we will have to understand what addressing modes actually are. So going to the basic definitions, addressing modes are the technique used by processors to specify the location of an operand in a memory or register. Each mode has its unique way of accessing data. Let's break down some common addressing modes. Okay, this sounds to be a very complex words joining together, right? Let us break down this and understand what actually addressing modes are. Addressing modes basically is a technique in which a processor can specify a particular location where the operands or the memory is. And each different addressing modes have different techniques to specify a particular location for the processor. So basically, in a computer, the addressing modes acts as a specifying location indicator. Okay, so I hope you understood this. Going on to the next slide, the first type of addressing mode is the immediate addressing mode. So what do we understand by the immediate addressing mode? By immediate addressing mode, let us go through the definition first and then we'll discuss what actually it means. In immediate addressing mode, in the immediate addressing mode, the operand itself is specified within the instruction. Okay, so I'll underline here that the operand itself is specified within the instruction. It's as if you are providing the data directly to the instruction. For example, if we have an instruction like add 5, okay, the operand 5 is directly provided in the instruction itself. Okay, so this is what immediate addressing mode does, that it adds the data, it adds the operand directly into the instruction itself. For example, as we've given add 5, the operand to 100H, the immediate addressing mode adds the 100H in the CPU memory as it is. So this is what immediate addressing mode is. So moving on to the next mode, which is the direct addressing mode. So what do we understand by direct addressing mode? I think we have gone through this. If we've seen this in our 12th standard, if people you have taken CS in 12th standard, so you would have definitely seen this, the direct addressing mode. In the direct addressing mode, the operand's memory address is explicitly specified in the instruction. This mode directly accesses the memory location containing the operand, for instance. For example, add 2000 directs the processor to fetch the data stored at the memory location of 2000. Simple as that, very simple. Let us go through this line again. The add 2000, which means that the processor is directed to fetch the data which is stored in the memory location of 2000. For example, let us take an example that we have stored um, our college name, that is Sri Venkateswara College of Engineering, and this is stored at the data at the memory location of 1200. When we tell that add 1200, that means we are directly fetching the data which is stored in 1200, add 1200, and that data is the name of my college, which is Sri Venkateswara College of Engineering. I hope you understood this. Let us move on to the next addressing mode. The next addressing mode is the indirect addressing mode. So, as we've gone through direct addressing mode, that we understood what do we understood with direct addressing mode? That it is very simple, that we are fetching a data which is present at the memory location. So, what does indirect addressing mode tell us? In indirect addressing mode, the instruction provided the address of a memory location that holds the actual address of the operand. It is like having a pointer to another pointer. For example, this whole paragraph looks very complicated when we try to read it. Now, by example, let us make it very simple and clear as water. If we have add 500 and the memory location 500 contains the value of 2000, the processor fetches the operand from memory location 2000. Wow, that's a great thing that indirect addressing mode does. What does it do? Let us go here again. That if we have the value add 500, that is add 500. What does the direct addressing mode do? It would fetch the data which is available at the index add 500. But what does this do? If we have add 500 and there is a value 2000 which is present at the memory location of 500, what the indirect addressing mode does is it would open the memory location of 2000. For example, let us read this again. Add 500 and the memory location 500 contains the value 2000 and the processor fetches the operand of the memory location 2000. That is, if we give add 500 and at the memory location of 500 we have the value of 2000, that means 2000 will not be displayed. It the look the what the processor the addressing mode does is it will open the memory location of 2000 and what present in 2000 will be displayed. For example, at 2000 I have my name, that is Irfan. What will happen if add 500 fetches you to the 2000, but it will not display 2000, it would display the memory location of 2000, that is Irfan. I hope this is clear. Let us move on to the next one. Next one is the index addressing mode. So we've gone through the direct addressing mode and we've also gone through the indirect addressing mode. Moving on to the next, which is index addressing mode. The index addressing mode involves using a base register. Very good. So we've got a register after three modes. So this is a point to be noted. And like a pointer and an offset of calculate the effective address of the operand. The offset is typically added to the value stored in the base register. This mode is particularly useful for the accessing elements in the arrays for a structure. For instance, add R1 plus 10 adds the value at the memory location address stored in the register R1 plus an offset 10. Wow. So what actually the whole game here is on this add R1 plus 10. We have a register, so we have given the register value R1 and plus 10. That means if we give any value to be added in the R1, that is at the register, and plus 10, the plus 10 goes to an offset of 10. For example, we've seen the register, also the register, and the operand 2. And in index, what it does is the operand R1, that is the register, the operand R1 value goes up to the 100. That is R3, R4, R5, and R6. That is 100, 200, 300, and 400. And the operand, that is the offset value is not being displayed in this picture, which is being shown. But then, if we take the actual example of this, we also will get the offset of 10. Moving on to the next one. The next one, my dear friends, is the relative addressing mode. All these modes, we have come to the relative addressing mode. So, what do we particularly understand by relative addressing mode? Let us just go through the points first and then we will discuss it with our own things. So in relative addressing mode, the operand's address is calculated relative to the program counter or some other register. This mode is commonly used for branching instructions where you want to jump to a location relative to the current instruction. For example, jump plus 10 will move the program counter 10 instruction forward. See, all these things addressing modes are built in the computer organization to make the work of the user easier by using and be by doing mastery in the addressing mode. What actually happens is that we get many tricks which would make our work easier in the computer systems. See, look at this. If we have to jump 10 instructions or 20 instructions forward, we have to keep pressing enter, we have to keep going. But the addressing mode here, if jump plus 10 will move the program counter 10 instructions ahead. For example, if you are in the memory location 1 and you press jump plus 10, that memory location 1 would jump to plus 10 and it would give you the output after jumping to plus 10. That is, it would give the present location, not the older one. I hope you've got this and let us move on to the next one. The next one is the auto increment addressing mode. What do we understand by auto increment addressing mode? See, auto increment is a word which we've been all hearing from long time. So it is simple as that auto increment, that is, it will be increased, it will keep incrementing automatically without any of the efforts of user. That is what we have heard. Let us see what it actually says. So this mode automatically increments the pointer or an index register after accessing the operand. It's handy when dealing with the sequential data structures like arrays. Okay, that is instance. For instance, if we have a load R1 plus, the processor will load the data from memory address stored in R1 and then increment the value of R1 automatically. Simple. See what does the load R1 does? What does the auto increment addressing mode do is if the we press the load R1, the processor will load the data at the memory address stored in the R1. That means simple. That is the processor will load the data at the memory address R1 and that R1 and then incremented the value in R1. This is what happens in the auto increment mode. Okay, after doing some we've learned about the direct addressing mode, indirect addressing mode, the immediate addressing mode, index addressing mode, relative addressing mode, and auto increment addressing mode. So after all this, let us try to summarize it and try to find the similarities or difference between these modes. So let us do the summary first. What does direct addressing mode tells us? Simple. Operand's memory address is explicitly specified in the instruction. As if we can recall or if you've missed it, you can just go back to the starting and we will get it again. That the direct addressing mode tells us the operand's memory address is specified at the instruction before only. Right. Now, what does happen in the immediate addressing mode? In the immediate addressing mode, the operand is directly provided in the instruction. In first one, the operand's memory address was explicitly specified, but in the second one, the operand itself is directly specified in the instruction. This is a difference between the direct and the immediate in addressing modes. Coming to the third one is the indirect addressing mode. In the addressing mode, the instruction provides the address of a memory location holding the actual address of the operand. Okay, so let us read it again and try to understand what does it say. Instruction provides the address of a memory location holding the actual address of the operand. Okay, the fourth one is the index addressing. Use a base register and an offset to calculate the effective address to an operand. Useful for the arrays and structures. And this is, to be honest, the index addressing mode is a little advanced one which would be used in high location defining structures, which is not for the present third semester people, so you can skip it if you want to. And auto increment addressing automatically increments the pointer or index register after accessing the operands, as if what we've read it just 2 minutes back. Okay, this is very helpful for sequential data structures like array. So if we've all read arrays in C plus programming or in the Python programming, that we know that array stores data and it automatically can increase the data. So it is very useful. The auto increment is very useful in arrays and data structures. That is all for today, ladies and gentlemen. This was just a brief explanation of all the different kinds of addressing modes. As we've seen, the computer organization and the different addressing modes. I hope that you have liked the video. And if you want actual and detailed explanation on every single addressing mode, please comment down below. We will be coming up with it. We will be coming up with a detailed explanation of every single mode. This was just an introductory video on the different kind of addressing modes, such just so that you can get an idea on what addressing modes are and what are its types and what actually are in its types. So, ladies and gentlemen, boys and girls, if you want any the upcoming next video to be about the brief explanation of every single addressing mode, please do let us know in the comment section, and do not forget to like the video and subscribe our channel if you haven't subscribed, and kindly do share the video with your friends so that a lot of people can reach the video and get the knowledge done. And as always, stay tuned. See you till the next video. Sayonara.